Good afternoon, everyone. Welcome to the Google Dublin Open House 2020 live stream. My name is Amanda, and I'm one of the engineering managers that works in the Dublin office. Today, my colleagues and I are super excited to tell you all about what it's like to work at Google and all about our engineering internship opportunities and other programs available to you. Really quickly, I wanted to go through the agenda for today's live stream. We are going to have the meat of our program will be about the programs and how you can create a good CV to get into the programs such as internships. And we will, in between each major talk, we will have a short lightning tech talk by some of our SREs who work at the Dublin office to give you an idea of what sort of technical problems we solve as SREs. But first, to kick things off, I'm going to talk a little bit about what an SRE or what SRE is. SRE stands for Site Reliability Engineering. Those of you may have heard of this book, the SRE book. We do offer it. You can view it mostly for free, I think, at google.com/SRE. And I think SRE is something I'm very passionate about. I've been an SRE for about 6 years now, and I've actually helped edit this book. So definitely recommend picking it up when you get a chance if you find yourself interested in the field after you've seen the whole live stream. But of course, I didn't bring you all here to tell you to read the book. Instead, you came here to hear about more about what the field is all about in general and have an opportunity to talk to some engineers and hear from some of the recruiters and the programs. So I'm going to talk a little bit about what SRE is, putting it into perspective on how it's all about scale. And I will also talk a little bit about how, as SREs, we measure reliability of services and infrastructure that we support. So first, let's talk about what is SRE and why is it a thing? So what is a site reliability engineer? We are a type of software engineer or programmer or coder whose goal is to keep Google working. We're expected to, hack the code, change processes, rework services, build tools, and educate our fellow Googlers on how to build and improve their services to make them more reliable for our customers. So typically, for instance, if Google goes down, knock on wood, we are the ones who respond to the outage. And we're also the ones who, after the outage occurs, works with the other engineers at Google to make sure it doesn't happen again. Why do outages happen at Google? They can be triggered by almost anything. So every time we update software, or anytime any service updates doesn't update, there's a potential to introduce a new bug into the system, which would cause the whole system. It may cause all the system to break. And also, even the hardware itself that you run your system on can break. So Google in particular works at a massive scale. We call it planet scale because we have systems and services that run all across the globe. We have data centers, I think, in almost every continent and in most countries to serve our customers. And what makes that wide scale even more complex to support as SREs is that users who use Google expect to get, lightning fast results from search really quickly and reliably. So that's why SREs are important at Google. So ideally, though, we want to minimize as much failures as possible. So I want to say like 50 to 75% of what we do as SRE is more proactive engineering. So our site SRE director in Dublin, Dave O'Connor, was once quoted in the Irish Times as saying, "I look for lazy engineers." This may sound funny, but it is true. We don't want people who are satisfied, doing the same mind-numbing task again and again. And we don't want just to act reactively when these outages happen. We want people who are able to identify potential problems and then design and build solutions that will prevent these errors from happening. So there's actually quite a lot of coding that as SRE you would do to kind of anticipate issues that can happen and build in that reliability piece. But again, as I described earlier, the other, 25, hopefully not as close to 50% of the time, it's more reactive. So similar to, maybe a doctor, right? We actually take on-call shifts and we go on call for our services where if something goes wrong with the service, we react to it. And we build a lot of tools to monitor our system to page us automatically. We also are heavily involved in debugging and troubleshooting issues as they pop up. And the goal is that we catch it before you would, and we fix it silently so that you don't know or you aren't affected by any issue. So a very mantra in S3 that we have is is hope is not a strategy. So this philosophy underlies most of what we do. We have this effort called DIRT, which is a disaster game where we completely model a disaster that we think could happen to a service and see how well our services hold up under the circumstances and how well SREs react to the outage. And actually, we have a speaker later who's going to talk to you about one of these outages and what we learned from it after I am done talking. The other big piece about the site reliability engineering philosophy is around reliability. Philosophy is around reliability and velocity. So you can imagine at a company like Google or any big tech company, it's very important to deliver features quickly and new features quickly. And this is often referred to as velocity. And you may think that as an engineer who's more focused on reliability, that might come into clash quite a bit. But that's not exactly the case. So in S3, our job is not to simply say, no, you can't release this feature. Our job is to work with the engineers who develop the new features to ensure they're launched safely, to ensure they're launched iteratively, slowly across the globe, and to make sure that as the engineers are designing the new feature, we make sure that they're aware of the standards that we set for the service and that they're complying with those standards. And we call these standards SLOs, or service level objectives. And I'll probably be saying that word a few more times during this presentation, and you'll probably hear it from other folks a few more times during this live stream. So now let's try to wrap our heads around the actual scale at which Google operates. So one of the lies about the scale is there's no such thing as an exabyte. An exabyte, for those of you who don't know, is a unit of information equal to 1 quintillion bytes, or 10 to the 18th, which is kind of hard to fit in your head exactly how big that is. But let's try to imagine it. So I'm going to kind of walk you through what this might look like. So let's assume that we have a printed page that has about 2,000 characters on it. An exabyte of text would occupy more than 500 trillion pages. Or another way to look at it is the city of Paris is about 105 square kilometers. So it would take about 1.7 billion of those sheets of paper to form a single layer on Paris. Still don't quite, maybe it's still difficult to visualize. But if we used all 576 trillion pieces of paper, they would cover Paris in a stack 33 meters deep, which is about 1/10 the height of the Eiffel Tower. And that's just one exabyte. So, and that's about, or that is the scale we're talking about when we're talking about how much data Google manages. So it's basically a 33-page layer that can cover the entire surface area of Paris, if you assume that many characters on the paper. And you think about, okay, where do we store that data even, right? A typical hard drive could hold 3 terabytes of data. And then you get into, okay, how long would it take to copy that data onto the hard drive? About 3 hours. So if you take a typical machine, it would take about a century, 115 years to copy an exabyte of data, which again, if you can picture what that data would look like, the layer on top of Paris, into about 350,000 hard drives. And at Google, this is the amount of data we need to copy in a single week. And the number of how much data we're copying is increasing day by day. And you can imagine with COVID-19, the requirements from our customers have increased quite a bit as well. So how do we solve such a large-scale problem at Google? We have a algorithm that we use called MapReduce, which the basic concept of it is you take 6,000 workers or whatever number you see fit, and you copy the data in parallel. So you're not just copying it with one source over time. And then if you do it that way, split it over multiple people working in parallel, you can actually get it done closer to a week instead of a century. And as site reliability engineers, this is sort of part of the major, or a lot of us solve issues with this way. And what can get complex about doing multiple parallel jobs is, how much infrastructure do we have to provision for this? There could be contentions, like if you have 2 workers accidentally transferring data on the same sheet at the same time. It could be that, instead of having one machine doing all the copying, if you have 6,000 machines doing all the copying, where do you, that's going to cost more money for the actual machines. So how do you weigh the cost versus the time that you want to execute the task? So, okay, we have this scale, but how do we measure the reliability of it? So what does it mean to be reliable? To be perfectly reliable, it means a service must never fail a query ever. But obviously, this is very difficult, perhaps, and probably isn't even possible. Google receives hundreds of thousands of search queries in a second. And while we can't reach perfection, we can get very, very close. And we find also that If we can get very, very close, it's good enough for our customers. So there isn't just reliable and unreliable. It's not binary. There's a spectrum. So let's say we get 10,000 queries an hour, and we end up dropping 10 queries to search due to network issues, due to maybe there's a small bug in the software. But still, if we only drop 10 of those queries, it's still 99.9% reliable. And we call this a 3 nines reliability, or a 3 nines service. And 3 nines translates to less than 9 hours of downtime a year. So instead of aiming for 100% perfect reliability all the time, this is the technique we use to measure reliability. So we can have 3 nines, so 99.9% reliable out of the year, which is about 9 hours of downtime a year. And we even have services that aim for 5 nines reliability, which is down for more than 5 minutes, not down for more than 5 minutes a year. But once you get to maybe 8 nines, it gets a little silly, because then you're talking about a downtime of 0.3 seconds. So it gets a little, sorry, my cat likes to photobomb me when I'm talking on live streams, apparently. So it gets a little, you have to find the right spectrum for your service, because it may be that you do feel confident that you could support 0.3 seconds a year. But usually at Google, 3 to 5 nines, we aim for that area. So again, it depends on what quality of service you want to offer and what your customers need, right? So like for your campus website, the website that students use to check announcements about the school, or to check, what courses do I want to take next year? It's probably fine if you have 40 minutes of regular downtime each month to maintain the website, especially if you announce it and plan for it to the users of the website. But if you tell all of Google's users, hey, we're going to take search down for 40 minutes every month, they might not be too happy about that. So it might seem like the answer is pretty simple, just don't break anything. But it's not always easy to reach a certain threshold of reliability. And I'm going to reveal a truth, probably a sad truth maybe. At Google scale, we're talking the global scale, something is always broken. At any point in time, some percentage of Google servers are down. We have planned maintenance to take down entire data centers. And we can also have natural disasters, right? Like you can think about hurricanes, flooding, any kind of storm that could also affect how well our hardware can serve user traffic. In addition, I talked about the launches, like new features, because of dependencies, right? Like the new feature you're launching, you may have it tested back to front, completely confident that it has no bugs, but maybe the infrastructure, you have a library that you depend on, that library might have a weird interaction with your new feature that leads to a bug. So launches are often where we, from the software side as S3s, we see failures getting introduced. There's also power failures, network fibers getting cut. I actually work on a networking S3 team, and I can tell you this happens by accident quite a bit. Data getting corrupted, or even us. Sometimes we break things while we're trying to fix them, not intentionally. All right, so with all these things that can break, how can you run a reliable service? How can you reach those 3 to 5 nines that you'd like. And the way we do it in S3 is something called redundancy. We like to have n+1 of everything. So this is the number of units we absolutely need at minimum to run the service. And then we add one more just in case one of those units goes down. And this applies to everything from rack switches, network routers, to machines, to even databases. So like for an example, to look at this, let's say your website takes 50 machines to run. They're all in one data center. Then in order to have n+1 protection from flooding in that data center or a wildfire, you'd need another building with 50 more machines in it. And having this redundancy is also very useful for other maintenance tasks. So this could be when we're rolling out new versions of the software, when we have to do a quick patch, And typically, actually, we strive for even n+2 redundancy in S3. So that means you can have one shard in reserve for doing maintenance, so typical launching new features, and then one if something happens while you're rolling out the new feature. So like if an unplanned or emergency happens. And we typically call this n+2. But of course, redundancy isn't easy either, right? Because failing over from one instance to your backup instance may fail, or there might be a miscommunication, or perhaps you haven't done the failover in quite some time, and the infrastructure doesn't quite fail over in the way you expect. So that's where S3 is coming again. And this is part of our mission, right, to help other engineers who are designing the new features. And we routinely perform tests to make sure that the failover mechanisms work. And we even build automation and design algorithms for the failover. And sometimes even we trigger the failover automatically so that a human doesn't have to push the button. It knows, or it can detect when there's an issue, and it has to automatically fail over to the backup shard. So at the end of all of this, we live to serve another day. And we have, we strive, right, to deliver the n+2 service, to deliver a reliable service, and also make sure that our customers are happy and that our customers don't notice when there's an issue and still can reach, YouTube, still can reach search when we're performing routine maintenance, or when there's an actual hardware failure and we had to move things without noticing. So that's sort of our mission. So that is the end of my spiel. I'm going to pass it over now to Christian, who's going to talk to you about a specific time when S3 responded to an outage on the networking side. Thank you.
Hi, I'm Christian Morini, an SRE manager in Dublin, and today I would like to give you a super quick view on what I work on. Each Google SRE looks after one or more products. Personally, I take care of large parts of Google networking. Let me tell you something about it. You can imagine it as a collection of data centers distributed all around the world, with fiber optic cables between them. If that sounds simple, the scale is a challenge. Remember that all Google services, including the entirety of Google Cloud, runs on it. How big is it? Well, starting from the outside, report says that typically 30% of total internet connection generated by billions of people is towards Google. The cumulative download on those connections account for approximately 12% of the total internet traffic, possibly more than that. There is already a lot of traffic, but it's only what goes in and out of the edge of the Google network. Internally, for each one of our customer requests, we need to do some more processing. And this requires many servers to talk to each other, generating much more additional traffic. Like if there was not enough already, it keeps growing aggressively every year, so the technological solutions used until yesterday are usually not enough for the future. See the amount of innovation that went on inside Google networking to be able to cope with the growing demand. Think about all the changes and migration that needs to happen every year to keep up with the pace. And still, SRE needs to keep availability up and prevent outages. Innovation means the entire new type of system gets added to the network, and we need to come out with new design to cope with them. For example, here in the picture there are dedicated appliances to support hardware-accelerated machine learning that became very popular in recent years to build Google apps and for our cloud customers. Taking the best performance out of these servers requires ad hoc network setup and further innovation. How much reliability this huge, ever-changing, and growing network needs? Our goal is the network should be the last one to fail and the one to fail the least. Why is that? It's obvious that network connectivity is absolutely critical for correct distributed service functioning, because without it, all our services stop working at the same time. You can argue that this is true for power, compute, and storage. What makes the network special? Well, power generators in different data centers are very independently from each other. Same for storage server and compute server, and this helps maintaining the availability. The network, instead, is inherently globally coupled. Many changes in the network behavior must be propagated to all the participants to allow them to cooperate. This means that network failures are most likely to cascade, to spread, and to have widespread impact. For the setup we offer to our customer, we need at least between 3 and 5 nines of availability. As you learned by now, this means that we only a few minutes a year of error budget for outages. That is not compatible with human reaction time. So SRE spends their time automating everything away. We call it automating the humans away. What do we automate exactly? These are the factors that plays a role on maintaining availability. Obviously, you want to reduce the number of failures. We call it the mean time to failure, which can be achieved with careful design of automation to take care of maintenance and rollouts. You also want to minimize the impact of each failure, having designs that shard the system in a way to reduce the blast radius of each component as much as possible. You want automation to help to reduce the time to detect a failure, because if you're not aware, you cannot react. Then SRE would like to help to reduce the time to diagnose the problem and perform a mitigation. We have built a dedicated solution that helps with each one of those aspects. What happens when things go wrong? Well, quite quickly, the impact for our customer is so big that you end up in the news, and we don't want to be there. On 2nd of July 2019, I was on holiday when 3 bugs in 3 different systems interacted at the same time to generate a major outage that lasted 4 hours. In this particular example, the first bug caused the automation that we have developed to maintain the fleet of our servers to start playing adversarial roles and practically attacking our network control application, bringing them down. We had systems in place to prevent maintenance to touch multiple critical servers at the same time, but the other 2 bugs created holes in that defense mechanism. As a result, my SRE friends had to literally run to the office to rescue the network using manual recovering procedure that took 3 hours to execute. What SRE generally do to prevent this? We study past outages and design prevention so that the same class of failure won't happen again. We call this the post-mortem analysis. We had a very deep post-mortem analysis for these incidents, and we came up with a set of design principles and relative changes to our automation to reduce the impact of this class of adversarial attack in case they repeat in the future. We started modifying all our rollout system to perform only incremental changes that are not allowed to proceed without checking that the network was still locally and globally healthy. It's important to check the global view to have a full informed feedback to the rollout activation. We also invested in making each single operation as hitless and safe as possible, and defined manual recovery procedure for them in case of disaster. All of these resulted in product enhancement and better automation implemented by SRE with the help of our dev partners. If you are interested to become a site reliability engineer, Google will be happy to speak to you. Have a look at the career opportunities available on our website. Thank you for your time.
Thank you, Christian, for going over a little bit about that network outage. Next up, I'm going to pass over to Ed, who's going to talk to you about the various programs and placements available to university students that we have at Google Dublin.
Thanks, Amanda. Hi, everyone. My name is Ed, and I work in the recruitment team here in Google, specializing in the area of software engineering and site reliability engineering. And today I'm going to talk through some programs and placements that are available for you here at Google. But first, I want to touch on this. So each one of us has our own story to tell. Our backgrounds and experience bring together new perspectives with a respect for how we think about our work and how we work together. So me personally, I started with a bachelor's degree in economics. I enjoyed the subject, but it was something for me that was missing. And I knew that it wasn't something I wanted to do as a career. In my final year of college, I was managing a bar in Dublin city centre. And coming up to busy periods, we'd always hire a lot of people. So we'd hire a lot of people for like coming up to Christmas and to deal with like working in the restaurant as well as working in the bar. And one aspect of that was I got to hire a lot of people. So I spent a lot of my days speaking with different people about what they're looking for, as well as what sort of a role they might be interested in. So it was really good. I loved getting that perspective. And that's where I went into recruitment. I just thought, you know what, like, this is something I'm interested in. How do I go about doing it? So I got a job in a small agency where I was there for a couple of months, basically. So I'd done 6 months there. The thing that made me change was I was traveling a lot. Okay, so I'd done it for 6 months, got a job then in Sigma recruitment. Again, I've always focused on IT recruitment. I then got a job in Google as a recruiter for the software engineering team. That was 2.5 years ago. So in terms of what I was looking for, it definitely brought me on the right path. So what we're going to do now is we're going to watch a short video on Google's mission, and I can show you then what attracted it to me.
So let's go into the office. All right, so this is our garage. Basically, nobody's in here.
Hi. I mean, we were all a bunch of kids. We were, we were all somewhat idealistic in our own way.
I did not inhale.
We wanted to do things that made a difference in the world and that, that mattered, right? That were interesting and hard. We didn't start out as a conventional company, and we never followed a normal path.
What is our mission? Basically, we want to organize the world's information and make it universally accessible and useful.
On the one hand, it was a perfect description of what we were trying to accomplish in search. And yet, it was also so broad as to leave the door open for all of the many, many directions we wanted to go in the future.
We set out to do something really useful for people, and all other things began to follow.
All right, so here we are in front of the elephants.
I don't think any of us possibly could have seen where this story was going to go.
It may sound nuts, but it's often easier to make progress on mega ambitious goals than on less risky projects. Few people are crazy enough to try, and those are usually the ones you want to work with.
What if distance wasn't a barrier to exploring our world?
Can we bring the internet to the 5 billion people who don't have it today?
如果世界上每一个人会说每一种语言，那会是什么情况？
What if everyone in the world could speak every language?
What if everyone could make a living doing what they love?
Everybody ready? Up, step, down, go.
Almost everything we do is an experiment in some way, shape, or form. Everything has some aspect of the unknown.
That didn't work at all, man.
You're probably going to fail a few times before you succeed.
And now the car is in control.
Google car in front of us.
We always tend to ask the question, how can we make it better? So there's always this sense of optimism and curiosity that you can make a difference.
If our ambition is to create products that have planetary impact, it's not good enough to just solve it for some people. You have to solve it for absolutely everyone.
The unifying theme, if there is one, is seeing something that doesn't work that well and trying to use technology to make it better.
Wow, I heard it. That is fantastic.
We want to get deeper into the problems that really matter to people and to the world.
Just because we've been successful in the past doesn't mean we're preordained to succeed in the future. That's why we need to keep on asking the big questions and work really hard to find the best answers.
So,
Oh, nearly played that twice. So I love that video personally. And to be honest, because it resonates a lot with the reasons that a lot of us work in Google. Okay, so as you saw, it's been 20 years since Larry and Sergey founded Google in 1998. And while the growth and the scale of the company have changed since those early days in Menlo, California, our mission of making the world's information universally accessible and useful has never changed. The mission is special to me because no matter what job you have at the company, whether it's in recruitment, tech, marketing, all of us are held to the same standards, which is ensuring that the projects and the products we're all working on are creating a meaningful impact for our users. Since all of us have different experiences and backgrounds, we don't all think or work similarly. For myself, I tend to work better in the mornings versus those who work better in the afternoons. I find that I'm more energetic in the mornings when I've had my 2 or 3 coffees before we start, especially on the way to work. What's great about working at Google is you have the flexibility with your working hours to match what you prefer to do and what way you work. By everyone having different perspectives and work styles, fresh ideas come from anywhere and anyone at the company. For example, Area 120 is a new startup inside Google, where small teams can pitch ideas and spend 100% of their time on an idea that might otherwise not be explored. So Googlers have 6 months to define and meet ambitious milestones, and anyone, whether you're in sales, tech, or anywhere, can join. You're also encouraged to explore things that you do and who you are, and there's a level of respect and support where you need it and make it a little bit easier on yourself. For example, we have employee resource groups, or ERGs as we call them, which are grassroots, Googler-initiated networks for supporting underrepresented employees with shared values of supporting diversity and inclusion. Some examples include the Black Googler Network, Disability Alliance, Gaglers, Greglers, Women at, Veterans and Hispanic Network. We also have industry-leading benefits like parental leave to take care of the diverse needs of Googlers in and outside of work. And while we still have a lot to do, we're committed to fostering diversity and inclusion by having an open dialogue, such as our Talks at Google series, which features innovators who challenge our thinking. They understand bias and they provide workshops to help you understand the impact, and sharing our workforce representative numbers, which shows our commitment to creating an inclusive culture for everyone. Having a diverse workforce is not only the right thing, but research shows greater diversity can increase performance, earnings, innovation, and better products. All of these examples bring us back to this core theme that we work together, not the same. Different perspectives, small teams, and opportunities to express ideas and make them a possibility help create an environment where every Googler can thrive. One of the things I actually really like about my team is we all have different expertise and experiences in recruitment. So this not only allows me to help with the training of new team members, but I'm always learning from my teammates. And like, I would have the least amount of experience in the recruitment team. And the people on my team really help me to see where I can be better, where I can do better for them and also for myself. Another one of the key aspects I love about working here is the personal growth opportunities. And they're available to keep you learning and growing. For example, if you wanted to work on your public speaking, programming language, manager training, or learn how to play the guitar or piano, we provide what's called Grow classes, which are learning and development resources led by Googlers. And we also provide educational benefits for you to take courses or trainings outside of work. We also encourage internal mobility. What's nice about being in a bigger company is that we have access to a lot of different product and project portfolios, depending on your passions and interests. We want you to own your own career and make those moves that work for you. What you're doing today may be something completely different, or if not, more impactful in 5 years than now. But if you don't want to change your role completely, you also have the opportunity on 20% projects. Even sign up on a rotation program or a bungee to explore different roles, teams, and places for a period of time. For a bit of my own experience, this is actually part of a 20% project that I currently do. So I want to increase the representation in Google of students coming from third level institutes in Ireland, across all of Ireland. So in short, we really want you to own your own career and make the moves that feel right for you. For us, it's about making sure that we provide resources and the internal mobility so that you and the role that you're currently doing can evolve over time and can evolve with you. Think big. It's part of a Googler's makeup. Challenging the way things are done. We call this constructive dissatisfaction. It's a quality we prize here at Google. It's that feeling of knowing that things could be better or that better answers are out there, and then you want to create them. It's not about criticizing. It's about reimagining, taking inspiration from one area of the world and then asking, what if? Because at Google, we aim high and we have high standards. In fact, when we aim 10 times higher. We don't look for a 10% improvement, which basically leaves you focused on building what's already there. Instead, we lean on bravery and creativity. We aim to rethink what's possible and solve the problem for everyone. And I love this quote by Larry. It may sound nuts, but it's often easier to make progress on mega ambitious goals than less risky projects. We're focused on solving problems for everyone on a global scale. And we've heard global scale mentioned a lot of times today. Googlers bring questions and then use Google's resources to help build the answers. I'm not talking about resources like our internal tools or our client list. Those are great and they set us apart. But what I mean are other Googlers, the people you work alongside, you learn from, you build with, and you befriend with. And the collective experiences we've had, our code base and our values that have been redefined and protected over time. Those are our most valuable resources. Take advantage of the fact that Google is big and use the learnings of other teams to help you build the answers to your question more quickly. Thanks to the questions we ask and the answers we give, we've grown beyond just a search engine. We're now building better answers that affect billions of people around the world, across mobile, video, and advertising, just to name a few. We aim to build technology that helps people live happier and easier lives. Products that change the way people access information, do business, learn, and connect with one another. It's not about making money at all costs. We want to use technology to make the world better, more efficient, and more effective. Being a Googler is all about wanting to do the right thing for all of our users. And Sundar said, we really want to help solve big problems in users' lives. We want to do it at scale, and we want to do it for everyone. So this is the part where I really want to focus on what Googlers are made of. So we're looking for people who are excited to continuously get out of their comfort zone, to learn new things, to ask big questions, and tackle new challenges. When finding our next generation of Googlers, we look for how a candidate thinks, their leadership skills, their Googliness, and last, and to be honest, it's probably the least important, role-related knowledge. Because we're looking for people who want to come in and make an impact on their teams right away, whatever team that may be. But we also look at what you can do in the long term. And that's the reason we hire by committee. We want to ensure that Googlers will add value across the various teams throughout their careers at Google, because we hope it will be a long and a fulfilling one. We hope that today helps you see that we're building a company where people of different views, backgrounds, and experiences can do their best work and show up for one another. So let's take a look at some of the roles that we have here. First up is our software engineering and site reliability engineering internships. First up, that these internships are full-time and they are paid. The start and the end date are flexible. And 2020 applications are currently open. And they're open to all students in their first year of university, all the way through to your final year, who study computer science or another relative technical field. And you can find more information at google.com/jobs/students. And you should apply for these roles as soon as the rec opens. So you should apply as soon as possible, because we review applications on a rolling basis. And students can intern in our Google offices globally. So when you apply for an internship within a specific region, we interview you generally for our internship program, rather than for a specific team or a location. Although we do ask you to indicate a preference of location. This gives us more flexibility to get you matched with a project across any of our products, such as Android, Chrome, YouTube, and any other project. The minimum duration is 13 weeks. Many of our new grad hires are previous interns, and it's an opportunity for us to test you, and equally for you to assess us as a potential full-time employer. Some people do multiple internships with us without even re-interview. And it's a chance to try out different products within Google or locations if that's something you want. And you, of course, need to perform well to get that opportunity. We also have our STEP program, or Student Training and Engineering program. They are also open. They're also full-time and paid. And to be eligible, you must be a first-year student of a third-year bachelor degree, or a first or second-year student of a 4 or 5 year bachelor degree. And historically, they're aimed at underrepresented demographics in tech. STEP interns are paired with 2 engineering co-hosts and 1 other intern in the pod for mentorship and support. STEP interns work on all product areas and on production level code in software engineering, site reliability engineering, and what we would call SETI, so software engineering tools and infrastructure. So you're also assigned a mentor outside of your current working group, and you participate in STEP-specific technical and professional development trainings. These internships are available across multiple offices in EMEA, but the dates are generally fixed, and it usually begins at the start of July and runs for 12 weeks. So let's have a look at what the intern interview process looks like. It is slightly different and more simplified than our industry candidates. So the process will start with a coding sample and a survey, where you'll provide more information on your technical skills and work style preferences. You'll also do a timed coding exercise, which takes around 90 minutes. Your recruiter will explain this to you in more detail if you get to this stage, and you must complete this in order to get to the next stage, which would be 2 back-to-back 45-minute interviews with 2 separate interviewers who do not share feedback with another. The interviews will include code that you write in the written feedback. After your phone interviews, you're given the opportunity to interview with specific teams and projects that have been identified as a potential match based on the preferences that you have submitted before this stage. Feedback from all of the interviews is evaluated together by an unbiased hiring committee that does not include your interviewers. And in that hiring committee, they will look at, first of all, how successful could you be in an internship, but also what can we add to you to make you successful? And then fingers crossed, you'll get an offer. Looking at how we apply, google.com/students to find the best role for you. It will have a various different roles, and you'll have the opportunity to look through and see which one fits you best. You'll also need your updated resume and transcript. It doesn't have to be your official one, but we do need something. And then you will submit. As I mentioned today, at Google, we are committed to dismantling the barriers that keep women and minorities from entering computing and technology fields. And we have a variety of scholarships and opportunities for undergrads and grads that you can learn about at google.com/students/scholarships. Our scholarship programs are as follows, including 2 new scholarships that launched in 2019. So the Google Generation Scholarship is formerly known as the Women Tech Maker Scholarship. The Google Generation Scholarship for Women in Computer Science, and it's relevant for students pursuing a bachelor's, master's, or a PhD in computer science or an other related field across EMEA. The Generation Google Scholarship for Women in Gaming is relevant for students pursuing their bachelor's, master's, or PhD in gaming or related fields across EMEA. Generation Google Scholarship for Women in Computer Science in Ireland is relevant for first and second year bachelor students pursuing computer science or related fields in Ireland. And it's for students pursuing master's or PhD or third or fourth year bachelor students with the intention to study further in Ireland can apply for the scholarship for computer science or gaming, depending on their major. The Google Europe Scholarship for Students with Disabilities is relevant for students with a disability pursuing a bachelor's, master's, or PhD in computer science or related fields across Europe and Israel. So the scholarship itself is an academic award. It's awarded based on, first of all, your performance within your degree, also your leadership, and the impact on the community of women in tech. You'll have the opportunity then to participate in professional and personal development trainings and workshops. And you'll also get access to a network of fellow scholars within the program. Okay? To be eligible, as I mentioned, and I'm going to go through this again just to make sure that we're all sure of it. So you need to be or intend to be enrolled in or accepted as a full-time or part-time student in a bachelor's, master's, or PhD program at a university in Europe, the Middle East, or Africa for the next academic year. And you must be enrolled at an accredited university. What your application will look like is you'll need an up-to-date CV. You'll also need up to 5 short essays on the following topics. So a technical project, leadership abilities, diversity in a local university, and passion for computer science. Academic transcripts for your current or prior institutions, if you have earned a prior degree, and a reference letter from your professor, instructor, advisor, or supervisor. So the applications are currently open, and they're open until December 4th, 2020. Moving on to coding competitions. We have 3 amazing coding competitions that run each year, and they offer a great chance for you to develop your programming skills, meet other coders, and have fun. If you're new to coding competitions, Kickstart is a great place to start. Kickstart hosts multiple online rounds of algorithmic challenges throughout the year, and you can participate in one or join them all. Hashcode is our annual team programming competition modeled on software engineering at Google. In Hashcode, your team tackles a Google-inspired challenge, like optimizing the layout of a data center or programming driverless cars. Code Jam is actually Google's longest running coding competition. and it's famous for its intriguing algorithmic puzzles. Code Jam takes place over multiple rounds and culminates with top contestants meeting at the World Finals, which is hosted at a different Google office each year. And registration currently opens around March of each year. Each competition is open to developers of all skills. We have one profile across all competitions, which makes it easy to compete in multiple competitions, so students can keep busy and keep developing their skill. If you do have any questions on this that I haven't answered today, codingcompetitions@google.com is the email address where you can reach the team. We also have a couple of other coding competitions where we're heavily involved. The IRL CPC contest is open for student teams with 2 to 3 members from Irish third-level institutions, and will test the participating teams on their combined knowledge of algorithms, programming, and problem-solving abilities. Prizes are often given to the top 3 teams, with a couple of the last previous prizes we've had have been the new Pixel phones. Okay, there's also the UKIE PC, which is the programming contest between Ireland and the UK, and IEEE Extreme. Open source projects are another great way to get some practical experience, applying what you learn in school. So that's all from me on programs and placements overview. I'll be back later on to talk you through some tips and CVs that's going to help you get that CV to pop, and we'll work across the host of different tech skills. And now I'm going to hand you back to Amanda.
Thank you, Ed. Next, we have Darinka, who will be presenting a lightning tech talk about another technology we work with and support in SRE, large-scale pipelines.
Hello everyone and welcome. My name is Darinka and I'm working as Site Reliability Engineer in Google Office in Dublin. First, I would like to give you some short overview of what Site Reliability Engineering is. Actually, why reliability? Because the most important feature for your product is that product works. All other features don't make sense if your service is not working. All the effort and time designers, software developers spend in building your service are wasted if product is not working. So SREs in Google are either working on a huge projects as Search or Gmail, or on a really important services as Google Payments. One of the main SRE principles is that we use a software to run a production. SREs are easily getting bored of repetitive tasks and they try to find a way how to automate it. Me personally, I'm working as an SRE in a team that supports a pipeline for data processing and making ads predictions. It's true that many things are really hard to quantify as user engagement and client satisfaction, but it's always useful to have a data and metric to support you making difficult decisions and goals. Enabling data-driven decisions is the essence of the information technology. It doesn't cover only the final result, it covers the whole process from data collecting through the data processing up to showing the final result to the user. Data must be kept fresh, accurate, aggregated, and contextualized in the right way to enable data-driven decisions. So, let's start building our data model for processing. We start with a small data set, and raw data usually doesn't carry that much useful information. So this data must be processed, aggregated, and labeled first. And once, when we have the useful information, we still have to figure out a way how to contextualize it and show a context to a user to enable data-driven decisions. Worth mentioning is that processing data takes some time, and we have to be careful to show the information to the user before the initial data expires. You wonder why this? Well, if we are monitoring the current traffic delay on the main streets of the Dublin, will it be the same if data processing and display time takes 1 day compared with 1 minute? You see the difference. Often, we have more than one data source, and it's actually a good thing because having all data processed together gives us a better context for aggregating, labeling the data, and also throwing out bad data or unneeded data. But also, having more data sources brings more complexity into our system because different data sources can have different policies about data, expiration time, creation time, then the policy concerns, usage contracts, regional laws, and stuff like that. Then, each piece of the data might have to be pre-processed locally before it can be aggregated with the rest of the data. So, when we're creating one pipeline, we can see that there are more challenges than just converting data into the information. The system must be sane for the engineers and data scientists to use it, debug it, and verify the correctness. And also, data must be kept fresh all the time. So, we have entered the world of the information pipelines. And as you can see, this whole process is a bit complex. The best way how to do it is actually to split this process into smaller steps where the input of one step, the output of one step is actually the input for the next step. On this way, each of the steps could be debugged and verified individually from the rest of the system. So, now when we have our data pipeline working, we have to think about other requirements. Those are performances and the data freshness. So, let's assume we have 3 different data sets, blue, red, and yellow one. Each of those data sets have to be brought together to our 4th site to be processed. How we can do it? We could use high-speed network and we read the data on the remote site during the processing. Well, how this could be wrong or how this could be improved? Well, if we remotely read the data, then our processing resources are setting idle since the time for transferring the data is longer than the time for processing, and this actually degrades our resource utilization. So, also, the network traffic could be a bottleneck here, and how we could improve it? Well, first, if we put some processing power in each of those sites, then this data could be pre-processed locally, filtered, and labeled before we do a final computations. In this way, we reduce the amount of the data that has to be transferred through the network, and then at the same time we also deal with the network capacity. Also, we increase the processing time because now we have processing all the data, all 3 different sets of the data in parallel. So instead of having X time to process the whole data, now we spend 1/3 of that time processing each of the data in each of the sites. Well, since the data is now smaller that has to be transferred to the 4th site, we can make a local copy of the data on the 4th site, do the processing, and serve the result locally. Now, let's take another look into our system. As we said, we have 4 different sites, and each of them are subject to different performances and then to individual failures. So I will try to give you some examples about different performances capacity on each of the sites. Let's assume that the blue site has too much data as the red and the yellow sites. Then we will need more time to process the data over there. Or let's assume that red site has too much capacity for processing the data as to other sites. Then the data processed on the red side, then the time for processing data on the red side would be way smaller than the 2 other sites. Or let's assume that the bottleneck is outside of our system. It can be a network. So I will try to give you some examples how we can bring more balance in our system and how we can overcome with those issues. So first, data redundancy. We could make one more blue site, like one more instance of the blue site, and then having the 2 instances processing the same data but different slices. This is how we speed up the processing time. Then we could apply the same on the 4th side and the network capacity. If we put more than one connection between the sites, then we could use more than one connection for transferring the data and removing the bottleneck from the network. Also, this network could be used for load balancing as well, not only in the failure modes. So, besides removing the bottlenecks, each of those sites is actually a system on its own, and as that, it's a subject to its own failure. I will try to give you some examples. Let's assume that the connection between the blue site and the main data center fails because a storm disconnected it from a network, or a ship dropped anchor on the internet cables, or just a nature chewing our cable. All of those situations are actually very likely to happen, and we have to think about them in advance to make our system resistant to those failures. One of the most obvious ways would be to fix this problem is to try to redo the whole process on the blue site. And then when that stage finishes, we transfer the copy of the data to a final site where we already have the data from the red and the yellow sites, and we do the final processing. You see, as we have the data splitted across 3 different sites and did the processing over there, now we have to repeat only 1/3 of processing instead of if we have only one site, or if we did the whole processing on the 4th site, we would have to redo the whole process. Now, let's think if our final data center fails and it becomes unreachable. It's our single point of the failure, and we have to find a way how to fix it. We will just build the backup instance, and we will have the backup instance to take over the work if the primary instance fails. Or even better, we could have both instances working at the same time, and as soon as one of them finishes, the other is halted. Or if one of them fails, the other will resume the work. So, as you could see, there are different ways how the system could fail. And as an SREs, it's our job to actually predict those failures in advance and prevent having them. So, but no matter what, incidents happens, and fixing outage quickly is actually straightforward. because you split the time spent for fixing the incidents to time to detection and time to the resolution. As an SREs, we try to minimize both, and effective incident response is actually a skill. You improve it as you practice it. And the irony here is that if you only practice the skill during the real outages, the more reliable you make your system, the worse you are responding to an incident. Because this is a magic circle. Once when you get paged for something, when something fails, you actually try to fix it, but you also try to make it gone, not to happen anymore. You try to automate it. And then when you get paged, you're getting paid for some new thing. And then you are fixing that one and preventing from happening again. And it's a magic circle. So I have tried to make it closer for you what an SRE job look like. And I really hope that you like it. And I'm looking forward to see you around the office. See ya!
Thanks, Darinka, for your presentation, especially going into detail about redundancy and some of the reliability tactics we use on SRE. So folks, we're about halfway through the live stream. So I'm going to give everybody the opportunity to get up, stretch your legs, grab coffee, grab food. We'll be back in about 15 minutes, so about 3:30 Dublin time. And when we get back, we will bring back Ed, who will tell you some great tips for creating like a eye-catching CV, followed by our Q&A panel with some recruiters for interns and also a past intern who managed to also succeed in getting a position at Google after their graduation. So we'll see you in 15. Welcome back, everyone. So as I discussed earlier before the break, I'm going to be bringing back Ed, who will be providing you some useful tips for making an eye-catching CV.
Hello again, everyone. For those of you who missed it, my name's Ed, and I work in the recruitment team here in Google. Earlier, I spoke about the programs and the placements that are available for you. And now I'm going to walk through some tips for writing that CV that's going to get the attention of the recruitment team. Okay, so first of all, why am I qualified to give this presentation? As I mentioned earlier, I've been working in the recruitment team here in Google for over 2.5 years. And before that, I actually worked as a consultant for some of the biggest companies in the world, such as Facebook, Amazon, and then more specifically in Ireland, Ryanair, KPMG, and EY, just to name a few. In this session, I'm going to share you some actionable tips on how to write a CV that, first of all, is more likely to get the attention of a tech company's recruitment team. Okay, although it's not specific to a tech company's recruitment team, this is just the stuff that us and some of the other tech companies look for. And also a CV that gives you the best chance of landing that interview, whether that be for an internship or a new grad position. It's also going to give you the chance to show a CV that makes a positive impression and will have an impact with that recruiter in that 30 seconds to a minute that a recruiter will spend looking at your CV. Okay, so we really want it to be eye-catching, and we really want there to be no doubt in the recruiter's head that you can do the job. So let's jump into the tips. First off, you want to demonstrate that you can code. We might see on a CV, I achieved first-class honors in Intro to Java, but why is this not a great example? The recruiter doesn't know the curriculum. Does it require you to code? Is it all textbook learning? A better example might be I created an app in Java that shows locations around campus currently offering free food, and then add a link to the GitHub, or if it's open source, to that open source project. This example is brilliant because it includes a link to the artifacts and code samples and evidence that you can code. Coding competitions are also great at showcasing your skills, as well as mentioning where you place. Okay, it's also a great signal for us because it shows that, one, you're doing it outside, it's a hobby, and it's something that you enjoy. The next example shows that you've got leadership skills and that the lecturer has confidence in you to be a tutor, to teach others. Okay, and that really cements the knowledge. And it's a focus on providing the evidence. Prove it to me. Every recruiter who reads your CV needs to see proof. We want it to be clear, and we want there to be actionable evidence. Okay, so just having, I have a keen interest in computer science is not good enough. Where we need you to stand out is as demonstrated by, and then going into some examples to give you some context. So volunteering for Code for All Ireland open source project for 2 years, which I contributed 5,000 lines of checked code. Checked is key because it's not just you writing code, it's checked code. There's someone else reviewing your code. And also serving as a Coder Dojo participant for 3 years, and then a mentor. Again, more leadership skills. And I've also got one more example on this topic. So we can also see here, again, is you're showing your tutoring skills. That shows more leadership. Okay, you're helping someone else. And that's a key quality that we look for when we're looking at CVs. So let's talk about the so what test. Make sure that every line that you put on your CV is relevant for that role you're applying for. Like sometimes we see things like avid soccer player, working in a bar or a shop. These things aren't really relevant to the job that you're applying for, but they are important. But these examples would fail the so what test. You have to remember that when we're looking at your CV and we're looking at the role you're applying for, you should also be looking at the job spec. So you can have the job spec and your CV in line. So showing this again, highlighting relevant experience. I was elected secretary of NetSoc, or the treasurer of NetSoc, which required me to become. So what other skills did you learn that helped you to be better at that job? So for example, we have here as a system administrator for the club. Quantify the impact. I wrote an app in Java that helps patients schedule appointments with the next available doctor. Or I refactored the code that lowered the average latency from 800 to 500 ms for an app that helps patients schedule appointments with the next available doctor. But why was what you did important? You need to quantify it and show results. So let's rephrase it and try it again. I created a database that allowed us to scale from 5K to 100K users. When we launched an app that helps patients schedule appointments with the next available doctor. And then I simplified the code for an app that helps patients schedule appointments with the next available doctor by removing 2,000 lines of code without losing functionality. As a recruiter, we want to see how your experiences are relevant to the role. What is your differentiator? What makes you different? And it's a really good idea to think about this. So tell us why you're a special snowflake, why you're different. Often we'll see things on CVs such as Intro to Java, Computer Science 101, or Advanced Math. It's not great because pretty much all of your classmates and maybe all computer science students in Ireland can say the same thing. So when we look at this, we want to see perspective. We want to say, okay, we have this amount of people applying. Okay, so on average, we receive 50 to 60,000 applications per year for an internship. Okay, and what makes you different? So this is the key to getting your point across. So instead, I want to focus on the things that make you unique. My third year project won second prize out of 15 entries in whatever competition it was. And this is a great example because one, it's giving me where you placed, but two, I can see how many entries have entered. Because again, we want to hire the best people. I want there to be no doubt in my mind that you can do the job. Whereas if you just said second and I don't see how many entries, I'm going to assume, okay, it could just be second out of three. Okay, another example. So I spend 15 hours per week at university help desk, assisting non-computer science students with hardware and software issues. I love this example as well because, first of all, you're helping someone. You're using your skills to help someone who's possibly not computer literate. Okay, and it also, this shows you, and one of the topics that we look at here is, we want you to be able to explain complex issues simply, in simple terms, or layman's terms. Or I created a pizza ordering app in C++ that is now used by 500 students campus-wide. That's giving us a great example of where you're currently at the moment. Okay, and it's giving me more of a reason to have no doubt in my mind that you will be good at the job. Don't pad it. Don't state the baseline that people would expect you to know. If you have to say these things, the recruiter thinks that you don't have anything stronger to say. So, for example, you're applying for a computer science internship or a full-time position. And one of the key skills that you have is I am proficient in using Mac and Windows operating systems. I have no technical background and I would consider myself proficient in those two systems. Or experience with Microsoft Office. Again, I would assume someone who, if they're in university at the moment, they're going to be using some sort of software to write and submit their assignments. So again, we really want you to be, first of all, be confident in what you're saying and set yourself apart. Substance over style. And this is a key focus because the content is what's important to us, not how it looks. So spend the most time considering what goes into your CV and less time on how it's laid out. You don't have to use non-standard formats or fancy fonts, images, or colors. Black and white and well structured. It's concise. This is what we look for because it makes my job easier. When we're looking at CVs, we generally have between 30 to 60 seconds. And I mentioned that earlier. That really is the only amount of time that you have to grab the recruiter or the hiring manager, whoever's looking at CVs. This is the only chance you have to get their attention. Short and sweet. 30 to 60 seconds is no joke. It's actually something we try and pride ourselves on. Okay? This is such an important point. We have to screen hundreds of CVs every day. We don't have time to read through paragraphs upon paragraphs of irrelevant information. Okay? So get your key points across in a single page or a maximum of 2. Okay, for a lot of you, this is your first time applying for an internship, or you're a couple of years in. So really, you shouldn't have more than 2. Okay? I've 4 years experience post my degree, and I don't have a 2-page CV. Okay? The only purpose of a CV is to get you the interview. The interview is what gets you the job. Okay? The CV just gets you in the door. And that's why it's so important. The devil really is in the details. Okay? And a lot of people might think, okay, I spent 4 days or 4 weeks writing my CV. But you need to be able to read your CV line by line backwards. Ask someone you trust to review your CV. It doesn't have to be a family member or a friend. It can be anyone. You just need to trust them. Another good place to start is if you have friends or family members who work in a recruitment company or in the HR department of a company. Okay, because these are people who look at CVs all the time. They understand the differences and what makes it different. Okay? Please watch out and correct typos. This is huge because what we're looking for is, and every role you will ever apply for, attention to detail is important. Okay? We want to be able to say, okay, if we give this person a job, are they going to miss minor mistakes? Are they going to have an issue with writing? Because this is a key information for us. Okay? So really avoid using typos. Just constantly look, spell check it, or even use some software that's available on the internet for you to do this as well. Okay? Avoid using acronyms. A lot of people don't understand the same, like you might be using a term in your current workplace, and we have a lot of them here in Google that other people, when I'm speaking, they won't understand. So try and avoid them where possible. Make sure your name and contact details are included. You could have the best CV in the world, but if there's no name or there's no contact details, how is that company going to get in touch with you? So you should always make sure it's updated as well. So make sure that if you've changed email address, or a lot of you would be using your college email addresses. Use your college email address if you intend to use that for a long time. Or, for example, if you're not actually in your college emails all the time, use your personal email address. Add your name to the file name. For example, my sample, in fact, it's the one I actually use at the moment, ed_Doyle_recruiter CV PDF. That tells you my name. It also tells you the job I'm applying for. So say if I apply through the wrong link and it brings me somewhere else, or it shifts my CV off to someone else, the person who's looking at my CV can understand, okay, he was applying for a recruiter position. And test all the links on your CV and make sure that if you include your personal website, that it works. Okay. A big example, especially for those of you who are interested in applying for technical internships, your personal website or your GitHub is a big thing to use if you're using it. Okay, so make sure that if you're making any projects that you create a GitHub and add it there. Sometimes the little things make a big difference. Don't exaggerate. This is a huge thing. If you can't back it up, don't write it down. If you put expert level down, then it's a recruiter's job to have you interviewed for a level that sets you up for success. Having expert means you could get a really, really tough interview. So let's look at these examples. I have expert level programming skills in C, C++, or I designed the C++ programming language. Let's take this into context. For example, one that I like to use is speaking Spanish or speaking another language. If you put that on your CV, I want to give you as many options as possible. And if you're coming on site, you could be doing 5 interviews. So a good way for me to say, okay, maybe I will try and get someone to interview this person in Spanish as well, because that could open up another whole layer of jobs that could be a fit for you. So now what I want to look at is what I would consider the winning formula. Okay, and it's a good thing to base all of the skills on. Okay, and I'm going to conclude on this piece. So this is just some advice that I've learned through working for many different companies, including Google for so long. And that is, I accomplished X as measured by Y by doing Z. Okay, it may sound simple in your head, but this could be the difference between you landing that interview or not. I have strong coding skills. Is this a winning formula? No, this doesn't even set you apart. It doesn't tell me much about you, your personality, or how good you really are. It's very subjective. So let's go, what did you accomplish? Okay, so I lowered the latency of an app that gives the shortest distance between 2 points, taking into account real-time traffic. This example showcases the what. So you accomplished X. This is what you did. Now let's add in the measured by Y. Okay, so how did we measure this accomplishment? So exactly the same phrase. I lowered the average latency of an app that gives you the shortest distance between 2 points, taking into account real-time traffic from 50 to 25 ms initial load time. Okay, we're getting there. We're making progress. It's good, but it's not great. I still have doubts. Now let's add in the how. And we're really big on this in Google. So I lowered the average latency of an app that gives the shortest distance between 2 points, taking into account real-time traffic from 50 to 25 ms initial load time by refactoring the code. And again, a little bit more detail, 1,000 lines removed without loss of functionality. That covers all bases. And you can see, even from reading that statement from I Can Code, you can see how much more informed, calibrated, and quantitative that this statement is. You've reduced all doubt in my mind that you can do this job. So thank you all. It was nice doing these 2 presentations, and I hope that you learned something today, whether that be what we look for in the students that are applying for the role across all levels, but also how to write a CV that's going to get you that internship. And now I will hand you back to Amanda.
Thank you, Ed. A lot of really great information there. For our next program, I'm very excited to introduce a couple of internship recruiters and a past intern to share their advice and experiences with you. We will be answering questions from those of you who registered for the event. But if you would like to ask questions, I think it should be below or to the side, to the right. If you want to post questions in the chat, and I'll try to get to those as well. So I'm going to introduce our panelists and invite them to talk about briefly what they do at Google. And as our first question from our registered guests, what is their favorite thing about working at Google. So first we have Katie.
Hi everyone. So my name's Katie and I work on the tech intern team within EMEA. I'm usually based within our London office actually, but obviously now working from home with my 7-month-old puppy Ralph, who is nearby to me now. So if you hear any barking, that's him. Now, my favorite part of working for Google is probably my wonderful team, mainly because they're there to support me a lot. Now, a lot of my role is actually supporting students through our hiring process. So for me to also have a really supportive team around me is super important.
All right, thank you. Next, we have Zara.
Oh, apologies, I was muted. Hi, my name is Zara. I work alongside Katie in the intern team, so part of that wonderful team that she speaks of. Thank you, Katie. And I work on roles across EMEA within the tech internships and also specifically STEP internships as well, which focuses on underrepresented groups. I would say my favorite thing about working at Google, kind of similar to Katie in terms of our team, it is great. And also just in general, the people and the culture, which might sound super cliche, but it is just, it's really great. Like, you know, it's really important to have good people around you to kind of enjoy where you spend most of your time, which is at work. And yeah, I'm also based in London.
Great. Thank you for joining us. And last but not least, we have Colin.
Yeah, hi, I'm Colin. I'm an engineer in the Dublin office. I'm an SRE. Before that, I actually interned at Google 3 times between the London and Dublin offices. So yeah, my favorite part about Google, it's probably, and it's going to sound cliche as well, but I really like being surrounded by smart people and being able to learn from them. Google has a great open engineering culture and it encourages people to share knowledge. And it's just a great way to learn and feel good about what you're doing.
Thank you for sharing. Right, so our first question from our registered guests is, what kind of projects or courses should I take if I'm interested in working at Google?
Yeah, I can start with something here. So obviously, a lot of what you do in college, if you're doing something like a computer science course or software engineering, is going to be relevant. But there are some things which aren't covered as much, which are definitely useful when you're at Google. So there are things like system design. It's thinking about how systems work together and what we can do to make them more reliable. Obviously, this is more of an SRE thing, but it's still something you want to think about. It's kind of this more large-scale thinking. And like any kind of project which you can show and which has some kind of like independent usefulness as outside of like a college assignment, is great, and it shows that you can do something, and if you put it up, it just looks great. Yeah, system design. It doesn't have to be something crazy. Like obviously, if you look at system design, it can look pretty scary, like setting up a huge Kubernetes cluster. But even just something basic and just having the mindset, it just really sets you up great for working in this industry.
Thanks. Katie or Zara, do you have any other thoughts?
Yeah, so I would probably, how to follow that. So yeah, I would probably mirror what Colin said about outside projects. So aside from your schoolwork, your university work, it's always great to see some other projects that you've actually completed, that you're interested in, that you're involved in outside your degree. So we can see that, you know, you do enjoy it. You're a really keen coder outside of school, and you get lots of practice, and that you really know what you're doing. So I would second what Colin said there.
I will add a little bit as well, if that's okay. Yeah, definitely keep improving and practicing. If it's a technical role, those coding interviews. And one thing I'm going to say on top of this is, if you're not successful the first time round when it comes to like interviews or getting a position at Google, don't give up. Keep working on those additional projects, improving those skills, and try again next year. When we're at university, a lot can change in a year and a lot you can learn as well. So definitely don't give up.
Okay, thank you. So previously we heard from Ed on some really great tips for making your CV pop for the recruiters. So this is perhaps directed to Katie and Zara. Do you have any additional tips, or are there any tips that Ed provided that you want to highlight as being particularly effective?
Yeah, definitely. Ed has already taken you through some amazing tips throughout that. So I was trying to think about it from my own perspective as a recruiter, because I know Ed mentioned that, you know, recruiters see loads of CVs every day. So what like really stands out? So from my own perspective, I think about the evidence related to the role that you're applying for. So again, on that project piece, think about the projects you've completed at university, any volunteering you might have done, any experience, whether that's internships or, you know, small, just a couple of weeks of experience you've taken part in. And if you're applying for a technical internship, we want to see your evidence in coding. So do show us that on your CV. When you're showing us all this information, make sure it's really clear and concise. It's super important that a recruiter can easily read through all the detail on your CV. And I know Ed's covered that already. And one thing I wanted to say is also be confident in what you're adding to your CV. In the past couple of weeks, I've spoken to quite a few students who have said, I'm not really sure whether I can add this in, or I don't feel like it's good enough, or I don't think you're going to be interested in it. But actually, like, we're certainly interested in it. So be confident in your achievements and be sure to add anything that's relevant to the role that you're applying for.
Amazing. Okay, I'll follow. I'll try and follow that. So that was amazing advice, Katie. I would say again, like Ed took you through some quite great tips that you can use, and I agree. Like, I think we've been looking at a lot of CVs recently, and I think from personal preference, sometimes, like, I would say I do sometimes like to see a GPA on the CV, and also exactly what Katie said. Like, I find with the preferred kind of coding languages and things like that, I think they're generally, you'll find they're always mentioned on the CV. But I think what we're really looking to see is that evidence that you can use those languages when you've used them, particular projects that you've been involved in inside and outside of university. So I think they're all really good, and just as much detail as you can provide as possible of where you've coded, where you've used these languages, etc. So yeah, those achievements and all of those evidences, really.
Thank you. Colin, we actually had a really quick question for you from the live chat. They're asking, why did you do 3 internships at Google?
Why not? So like I got lucky enough to have an internship in my first year. So I basically did an internship every summer during college. Why do 3 of them at Google? I like Google. I didn't feel like once I'd done one internship that I'd done everything. I feel like there was definitely a lot more to learn. And yeah, no, it was a great experience. So I came back.
We were glad to have you come back. So from our registered guests, we had a pretty tough question, which is I'm a mature student who would like to work at Google after graduation. Would my age affect my chances of getting accepted into the company and being successful at the company?
Right, I will jump in for this one. So I'll start off by giving a short answer, which is no, age is not going to affect your chances of getting accepted into the company. I will expand a little bit more now, though. So that we are committed to equal employment, regardless of your age. We're looking for people who are curious, collaborative, excited about tackling some of the problems we have in technology. So in that case, like, we certainly want to hear from you. I'll expand on kind of the eligibility side while we're here. So when it comes to eligibility for some of our student roles, for internships, you should be going back to study following your internship to be eligible. Unless your university requires an internship as part of your course, then we can consider it. And if you've just started final year and your university doesn't require that internship, then you can be eligible for our graduate positions at that point. Now, I just want to touch on the second part of the question as well, about, it mentions about being successful at Google. And I think I could talk about that all day. So rather than doing that, I'd certainly recommend taking a look at diversity.google.com, because that talks a little bit more about our feeling of belonging at Google and how we're creating a more inclusive Google. So like I said, I could talk all day about our employee resource groups and so on, but I definitely would encourage you to go and take a read there.
Sorry, one moment. I'm having some technical difficulties.
That's okay.
I think my voice is coming through, but I can't quite hear.
I'll just add something.
But I will ask the question, and you can answer while I try to figure this out. So this is a question for the recruiters again. Will remote internship opportunities be available?
Sure, I can take this one. It will be a fairly brief response to this one. Hot off the press, our internships will be virtual in 2021, meaning that absolutely, yes, they will be available. So it will work similarly to how it did this year. You'll be expected to kind of work remotely from where you are. And that doesn't, a question that I find I have most often at the moment is, does that mean I have to be matched to, if I'm in London, I have to be matched to a project in London? No, that is not what that means, just to clear that up. You can still be matched with any team in EMEA as long as the time difference isn't too wild. I think it's over 3 hours or something like that. But yes, you can absolutely, if I'm in London, I can be matched to a project in Munich, and that's absolutely fine. So yes, they will be available, and you'll be able to work on any project in EMEA from wherever you are in EMEA. Also.
Okay, people have stopped talking, so I assume I can ask the next question. I'm going to actually take one from the live stream again, which is we have one viewer who has experience as an Android engineer. How relevant is this experience to being an SRE at Google?
I guess I can start and say something here. A lot of engineering skills are transferable. If you're worried about like having a certain skill and worrying if it's going to be useful in Google, a lot of the time when you start in Google, you're not going to know any of the technology anyway. Everything here is kind of its own thing. But because of that, there's great resources for learning these things, ramping up. So I think being an Android engineer will still let you have the skills to be successful at Google, and even as an SRE. There's no real worry that you're boxing yourself into somewhere specific.
Yeah, I will add to that. I really like that answer. And what I'd say is when you're applying to different positions, have a look at those. There's always a few minimum qualifications. So have a read through those. But also don't think about it too much. You know, if it's a role that looks really interesting to you, like give it a shot. Because if we think you've got some really great skills, a recruiter will reach out to you and talk to you about it. And we'll think about, okay, is this the best role for you, or could there be something else? So have a look at the minimum qualifications. If you've got those, great. Don't be worried too much. If you've got some experience, fantastic. Like, go for it. That's a great start. Okay, ready for the next question? All right. All
All right, so Ed went over the interview process for STEP and classic internships a little bit, but I was wondering if perhaps Colin, you could talk about your own personal experience going through the internship process, and then Zara and Katie can give any other tidbits for their respective programs that they recruit for.
I was talking about the interview process. Yeah, okay. So I can mostly talk about my side of the curtain. I'm not really aware of what happens on the other side yet. All mysterious. So I applied back in 2017, and it went through the process, and I got 2 interviews, which I think is pretty standard for internships, especially STEP ones. Yeah, and so they were remote interviews. I got on a video call. Guess we're all used to that now. And yeah, they were technical interviews. So most interviews you do with Google will be technical. They'll be testing your skills. It's not about evaluating you as a person as much. It's about evaluating how you can solve problems. When I got into it, for some reason, I was surprised that it was just some engineer just in an office in Zurich, I think. And it was just someone who did some work. It wasn't a dedicated interviewer. It was just, some person. And yeah, and they were really helpful. Like it was a great experience. It kind of feels like they want you to succeed. They kind of nudge you along if you're stuck on a certain point, but they really are looking at how you solve the problem and, what your process is as you go through it. I feel like I didn't do great in my first interview, and then the second one was good. So I think I got a third one out of that, and then that went fine, and here I am. I haven't done any interviews since, so I don't really know if anything's changed massively, but yeah, that was my experience.
Cool. I will give it from a recruiter perspective. I know Ed's taking you through the full details, but I want to give you the idea that you will be talking to people just like myself and Zara. It might even be one of us taking you through this process. We are there to guide you through it. And although it can seem super scary, like the first thing is just submitting your CV. Once you do that, then you are on your way. We are here to help you if you're feeling nervous, if you're feeling concerned about interviews, if you have any questions, and simply you can reach out to us anytime. So please do that. If you're assigned a recruiter and you're going through the process, don't hesitate to ask questions. That is what we're here for. I'd also give an idea just on like timelines as well. It can take a little while to get through all the processes for intern hiring. Submit your CV, you've got a questionnaire to complete. Then you get to your interviews. And if you're successful there, you're reviewed by what's called a hiring committee. Then we go to our intern placement interviews. So there can be little gaps between each part of the process. And a good rule of thumb is if you haven't heard anything for maybe 2 weeks, then give your recruiter a little nudge and ask for an update, and we'll be absolutely fine to do that. If you have anything to add, Zara, to that.
That was quite succinct, Katie. So from a perspective, it's pretty much exactly that in terms of the STEP team. Like we will review your screen your CV, then invite you to the 2 technical interviews as mentioned, and we will give you an outcome hopefully like fairly quickly. I'd say about 2 weeks as well. So I think, yeah, that's right, Katie, about 2 weeks. We'll probably give you an outcome for that interview, depending on when it's scheduled. And then after that, there's the intern placement interview stage, which is where it's also known as the post matching as well. So that's where you'll be matched with a project. And at that part of the process, you'll generally start having conversations with hosts who will hopefully in the future become your managers, and they will talk to you a little bit about their project. And it's less formal than the technical interviews that you've had already. So don't worry, the technical part is already over. Hopefully you can relax a little bit by this stage. And now it's just you both getting to know each other, conveying your interests and your experience and everything you've written on your CV and your questionnaire, making sure you can talk about that. And then the host i.e. your potential manager, to then discuss their project, and then you see if you're both interested in continuing, and then hopefully at some point that does lead to an offer.
Okay. Our next question is again from one of our folks who reserved spot, and this is for Colin again. Can you describe a typical day for an intern at Google?
Okay. Well, typically I start by going to the office, which is this building where we used to work, but I don't know. And then it's kind of depends on what you're doing at the time. Like you'd obviously sit down, check your emails, say hello to the team, and then you'd work away your project. Project work can be a bunch of things. It could be working on designs or fixing bugs or whatever, technical stuff. And then like our teams, all the teams I've been in so far have had like a stand-up before lunch where the team gets together and talk about what's going on. And it's a great experience. It's a great time to like see what everyone else is doing. As an intern, you can often feel like you're stuck in your own project. So it's great to see what's actually happening in the team. And then we had lunch. Lunch was great. It's just a time for the team to relax and just chat. And it's also a great time to just ask any silly questions you have as an intern. And then then the other thing is there's a lot of one-to-one meetings. So you often have a one-to-one meeting with your host or someone in your team. And that's also a great chance to just ask questions and just, get up to speed with stuff. And it's a really nice experience because people are there like dedicated just to help you. And it's nice. Other meetings. So you'll realize that your team has loads and loads of meetings. You can see anyone's calendar and it's just full of stuff. You don't need to go to all of them as an intern. You're kind of working on your own project. But if it's interesting to you, you can. So I went to a few of the team meetings, like a production meeting, where people talked about what's going on in the week, and then other like long-term team plans. And it was very interesting. It's just a great thing to experience and learn about. Other than that, so usually, when I was there, there's also lots of interns in the office. So you kind of tend to make friends with them, build a nice network. If you need a break, you can go chat with one of them or, play table tennis or something. I think that's most of what I'd like to say. It's kind of, it just happens. It's a nice experience. Sorry.
My mic was muted, right? Yeah. So we only have a few minutes left. So I'm just gonna perhaps go around. Oh, we have one more question here. So how many people who have host matching interviews get an offer?
So this is a really interesting question. And I must say, I don't have a full answer for you, but I will hopefully give a little bit of context and some advice for it as well. It really does change. There is no guarantee that we will find you the right project match, but there is certainly some ways to help us find one. I'd say one thing is you'll be given a questionnaire to complete. Do take some time in completing that. Put in plenty of detail about your experience and your preferences. And when thinking about your preferences for a project as well, do remain open. If we have got teams interested in your profile, we say take a call with them, even if you're not sure, because it might surprise you. So actually, you can really help us with this. If you stay nice and open to the projects we have available, then we're more likely to be able to find you the right match and you'll be successful in finding an internship. So not a complete answer for you, but a little bit of advice to help with it.
Hey, thank you, everyone. I think that's about wrapping up most of the questions. So I will let each of you maybe say a farewell, and if you have any last bit of advice for everyone watching as you go. Let's start with Zara.
Sure. So I would say now is a really great time to get your application in. So the earlier that you apply, the better. Please have confidence in yourselves through your CV and in the interviews. Make sure you prepare. Preparation is really important, and we'll always make sure that we provide lots and lots of resources for you to be able to do that. So you give the preparation your all, especially for the technical interviews, and through every point of the process. Reach out to your recruiter, myself and Katie, or similar, for any kind of advice that you might need. We're here to help. We want to see you succeed and do well.
Okay. Rotate over to Colin.
Good luck is what I can say. Keep working on side projects. They really are great, both in terms of looking good in your CV and just giving you great skills. I don't think I have much else to say, but yeah, good luck.
And finally, Katie.
Oh, well, thank you for having us here to answer a few questions today. I will absolutely mirror what's already just been said. Have that confidence to put in the application. Enjoy the process as well, especially when it comes to the interviews. You're going to be nervous, but try to enjoy it, because whatever happens, you're going to get a great experience out of it. And hopefully we'll be speaking to a few of you over the next few weeks when it comes to the hiring process.
Well, thank you everybody for joining and sharing your experiences, even though I couldn't really hear anything. I'm sure it was all lovely.
Thank you.
And I will see you all again. Yeah, N+1, right? I get my extra mic just in case my professional mic went out. But next up, we have our last lightning talk for today. Gundas will talk to you about CAP theorem and how we apply it at Google.
Hello. In this section, we will hone in on a famous trilemma of distributed systems called the CAP theorem. CAP stands for the three components of the trilemma: consistency, availability, and partition tolerance. These are related to safety, liveness, and correctness of the system. After defining these terms and describing the CAP theorem, we will delve into implications and some practical applications. The first component of the trilemma is consistency. Consistency in a system is defined as every node providing the most recent state of the system. If a node does not have the most recent state, it will not provide a response. This, as you can tell, builds off the idea of safety, because it refers to something that will never happen. Consistency in a system says that no two nodes will return a different state at any given time, and that no node will return an outdated state. The A in CAP stands for availability. Availability in a system means that every node has constant read and write access. In other words, an available system allows me to make updates and retrieve the state of the system without delay. This, then, is born from liveness. Availability promises what must happen, which is the ability to read or write some state. Component P in CAP stands for partition tolerance. A partition is an inability for two or more nodes in a network to communicate with each other. If a node A cannot receive messages from node B, or vice versa, this means there is a partition between the two. You can consider partitions to be the equivalent of unbounded network latency, meaning that messages will not get to their recipient. Partition tolerance, then, is the system's ability to function in spite of partitions within the network. Partition tolerance is more difficult to categorize, but it also falls in line with safety, as it specifies what will not happen. Partition tolerance states that the system will not stop functioning even with partitions. What's CAP theorem then? It's a simple statement. A system can only have two out of the three of these properties at any given time. The choice must be made between consistency, availability, and partition tolerance. We will give you a quick proof in just a second as to why the CAP theorem is true. In order to prove the CAP theorem, let's run through some examples. In each example, we are going to give an example of a situation in which choosing two properties forces us to yield the third. In our first example, let's choose partition tolerance and consistency. We will see how that ends up sacrificing availability. Imagine I use a system to store my favorite color, and my favorite color changed from blue to red. I sent the update to node 1, which then sends the update to the other nodes. Coincidentally, there's a network partition between the node 1 and 3, and 2 and 4, which means node 1 and 2 cannot communicate to node 2 and 4. So after the update, node 2 and 4 is still ignorant. Then I query node 2. So what will be the expected behavior? Since node 2 is bound to consistency, it chooses not to return anything. The bad news is we get no information, but the good news is we get no outdated information. If you are wondering how node 2 knows it's outdated, we can say that it first asks all other nodes for updates before returning a state. If it cannot receive messages from all nodes, it will assume it has outdated information and refuse to return a value. Therefore, the system becomes unavailable for this query. ATM machines can be considered as an example of such system. If you deposit in one and withdraw from other, the second one needs to know about the transactions. And if it cannot tell, it will not allow withdrawal. Our second example, let's choose partition tolerance and availability. Here is how we lose consistency. I send the update to the system. My message happens to go to node 1. Node 1 relays to update all other accessible nodes, which update their state. Nodes 2 and 4, however, cannot receive messages from other half, so they are not aware of the update. I later query node 2 for my favorite color, and node 2, according to our choice of availability, will return its current state. However, this is not the most recent state, as the most recent update was red. Because node 2 provides the state that was not the most recent, it was not consistent. A typical example can be considered as a comments feed for a user-generated content. One can still see a list of comments, but the freshness is not always guaranteed. So let's now see consistency and availability. I send an update to node 1. Node 1 passes the information around. I query node 2. It returns a value to me. Great. Everything is working as expected, except there is a problem. If we throw in a partition, this wouldn't work. If we throw in a partition, we are forced into one of the first two situations. And this proof demonstrates the spirit of the CAP theorem, that the system must compromise. So now you understand the CAP theorem. However, there are a few notes to include your takeaways of this talk. And those will let you better appreciate the CAP theorem's significance and implications. First, although our proof used extremes, these three properties are not always black and white. They are instead on a spectrum. For example, instead of never returning a value to stay consistent, but give up all availability, a node might wait for 5 or 10 seconds before giving in and returning some value. In addition, there might be unbreakable partition in your system, but network latency may cause state discrepancies. Instead of discussing the CAP theorem in absolutes, consider compromises. In addition, almost every reasonable system will assume that partitions are going to occur in the system, meaning that choosing P as one of the two properties is a given. For that reason, CAP theorem often reduces to a dilemma between consistency and availability. The choice is whether it's preferable for the system to return a false or outdated value, or simply not return a value at all. On this choice hinges all the implications of CAP theorem. Let's consider a system with replication factor of 3, and imagine we have the ability to tell how many of these replicas are sufficient for a request to be fulfilled for a given write or read operation. A write request with an R value of 2 then means system will respond to the request as soon as 2 of the 3 replicas successfully complete the write. In this scenario, even a network partition renders the third node unreachable. Write request will still succeed. And when at a later time we read from another node in a state where there are more network partitions, we can still read up-to-date results. There will be a limit to network partition tolerance under these parameters. If we tell the system that for a read operation, one node's response is sufficient, we will then favor the availability over consistency. Now that we understand the crucial considerations for designing a scalable distributed system, one might inquire about the right technology. Google Cloud differentiates by providing an extremely reliable network infrastructure in a way that a database service such as Spanner practically satisfies all 3 components of the trilemma. Unlike most wide area networks, and especially the public internet, Google controls the entire network and thus ensures redundancy of hardware and paths, and can also control upgrades and operations in general. Fibers will still be cut, the equipment will fail, but the overall system remains quite robust. For much of the last decade, Google has improved its redundancy, its fault containment, and above all, its processes for evolution. Building systems that can manage data that spans the globe, provide data consistency, and are also highly available is possible. It's just really hard. The beauty of the cloud is that someone else can build that for you, and you can focus on innovation core to your service or application. In that note, we conclude this section. Thanks for joining, and have a great day.
Thank you, Gundas. Well, folks, we're about ready to wrap up, so I am going to pass it over to Rory for our final presentation, who will give you a little short take on why you should consider a career in SRE.
Thank you, Amanda. Hey, everyone. It sounds like you've had a pretty good afternoon. So I'm Rory Ward. I'm an engineering manager here in Google Dublin. So I'm going to wrap it up and give an idea, another idea what it's like to work in SRE in Dublin and why you should come and join us. So the first is, like, you've heard a little bit about scale for SRE. So we do run services. They are used by hundreds of millions of users. That's a pretty big deal. And so that results in lots of times we work on like really difficult, challenging problems, like large monster Rubik cubes running down a corridor. These things actually happen. But anyway, so the important part is that we do work on these huge, really significant issues. So if you like to work on challenging problems like this, you really should work at Google in Dublin. The other part is that although these issues do go on, you're not expected to work on them on your own. So we do tackle these problems, and we tackle them as a team. So there are some like really pretty impressive people in Google, actually in all parts of Google. And we work as a team. We have very inclusive, very diverse teams, and that's what we do to tackle these problems. I'm not so sure about that guy who's facing towards me. It looks like he might get killed. But the important part is that here is that if you like working on these challenging problems and you do enjoy working with really talented people, you should also strongly consider coming here, because it's pretty cool, to be honest. The next is relation to the scale of what we work on in terms of the scale of the compute technology. So we have data centers all over the globe. We have very, very large numbers of servers. Effectively, what we work on is a very, very large computer, huge big screen, huge big keyboard, but huge big compute resources. And that is a tremendous power and the SRE has for managing these huge services. And along with your most favorite superhero, with great power also comes great responsibility, and we do take that pretty seriously. So effectively, when you work here, you are a superhero in a sort of planet scale computer way. So nice. So if working on such large amounts of technology like planet scale compute problems, planet scale compute technology, you should come and join us. And last but not least is the support that we get. So within this context of these very difficult problems and huge compute that we work with, we are supported incredibly well. So we are cocooned by a halo of stuff. Most, if not all, is free, whether it's free food or free gym or free drinks or free gaming systems. They're all there. Basically, the idea that we have here is that all your sort of basic needs are met, which means that we can concentrate on all the sort of cool, difficult problems that keep us pretty excited. So that's what it's like to work in Google in Dublin. So I guess in summary, what I'd say is if you like to work on like really technically challenging problems, to work with really talented people, work on amazing amounts of resources in terms of the type of scale that we work with. And you also quite like free stuff, or to be supported in doing all that, you really should come and work in Google, because it is a pretty cool place to work. Now, with that, I guess I'll do just a bit of a thank you. I do want to thank everyone who helped organize this fairly amazing event. I want to thank the presenters, the collaborators, the volunteers, and the AV people. Everybody helps to make it happen. I want to thank you for participating and showing up and asking your questions. That was very good of you. And then I look forward to seeing you, hopefully in person sometime next year. And with that, I'm going to hand it back to Amanda. Thank you very much.
Thank you, Rory, and thank you all so much for attending this live stream. We do plan to host this open house event, again, hopefully in person as we usually do next year. And typically for our open house event, we invite students to actually visit our Google office, and it's more of a full day event, and you get to actually mingle with way more Googlers and ask really specific questions. So keep an eye out for those communications. And if any of these internship programs or placements interested you, please follow up on the websites provided by the various recruiters. And I hope you all have an excellent evening. And hopefully I will also see you in person very soon. Bye.